Do you know how to get the maximum stress and deflection for a particular circular element in STAAD? And also you can get all the stress values in the STAAD output. Welcome back to Civil Nirman, where we turn complex structural concepts into practical insights. Welcome back to Civil Nirman, where we turn complex structural concepts into practical insights. Today we are diving into another sample manual validation problem that we will verify with the manual calculation with this STAAD. So let's start by understanding the problem that we are tackling. As you can observe over here, we have a simple locomotive axle sample problem with a diameter of 10 inches which is subjected to a load of 26,000 pounds at these 2 points. Now the problem is to find the maximum stress and deflection at the middle of the axis. So we have following dimensions, as you can check out over here. The material's modulus of elasticity is specified in the sample problem. Now see, I wouldn't be modeling the STAAD model from the scratch today because that particular part you are already aware. Instead, I'll walk you through the basic geometry and load setups. So let's check it out in the STAAD model and validate the results.
As you can observe over here, the geometry is pretty simple. We have 4 members and I have placed the joints at the critical points as described in the problem. Here I have created one additional node at the intermediate location over here. Okay, and for the loads I have applied a downward force of 26,000 pounds at the outermost joint, which simulates the real life loading condition on the axle as described in the sample problem. I have also pinned the support at the 2 inner joints to match the boundary conditions described in the problem. Now see, the material properties are essential to get the accurate results, right? So I use STAAD editor to match the materials with the problem's value, which is the elastic modulus value provided in the sample problem, and this was defined under the define material command in the editor. Similarly, if you want to create that particular segment, I have specified over here as material 1. Okay, you can click on this create option and create a new material. Similarly, I have defined that particular material and added the value over here with the Young modulus and the Poisson's ratio, and the same is assigned in the property tab. And you can check out this particular segment as well. The material property is assigned. Now let's run the analysis. Now see, in order to get the values of the member stresses and joint displacement, additionally you need to specify that particular segment in the command. I'll click on the editor option, and over here, in order to get the member stresses, we need to specify these 2 commands. So I am adding that particular command after the perform analysis. Print member stresses. Let me make it capital. Similarly, I will add another command for print joint displacement. Right, let's save it and let's run the analysis. You can check out the pipe segment. I have specified the pipe property. Okay, those who are so don't get confused. So for the property part, we have specified 10-inch diameter pipe over here, so don't get confused with that particular part. Now let's run the analysis. So this particular commands allow STAAD to give us the detailed output for each node and member in this structure. So let's check out this particular in the STAAD output. So I'll click on the output. So once I click here, you can observe that we have this particular member stresses at each particular location, right? And we are getting value as 3575. Similarly, if I click on the other segment, the joint displacement part, so basically if we observe the STAAD element, I'll switch on the node numbers. I want displacement at location 3 at the midpoint, right? So you can see over here the value displacement that is provided is 0.01037, right? So similarly you can check out your member stress values and joint displacement. Now let's break down the member stresses with the manual validation. So I'll minimize this, we'll go to the STAAD segment. Now in order to work out the bending stress, this particular segment we have already learned in our graduation, right? In the strength of material, to calculate the stress we need to follow the following equation: M by Z, and Z, that is your section modulus, is ultimately I by Y, right? So first of all you need to work out the bending moment, then you need to work out I and Y. So for the circular element we already know that I is in the form of pi by 64 d raised to 4, and if we want to work out the section modulus, right, then it will be pi by 32 d cube, right? So you need to put ultimately work out this moment value and I value, so you will be able to calculate your stress value, right? So ultimately what will be the bending moment? See, the bending moment will be the load which is acting, and at the middle portion that we need to work out, the bending moment acting in the middle portion of the axle will be your load into the distance, right? So ultimately 26,000 pound is the load, and the distance that is specified is 13.5. so I'll get the value of bending moment. You can calculate in the calculator. Same equation can be utilized over here as M by Z. So I'll work out the value. I have put the section modulus value directly over here, and we already know the bending moment M value that we have worked out, force into perpendicular distance, right? So I'll get round about the value as 3575.3 pound per square inch, and the same value we are getting here in the STAAD output at node 3. So I'll click here. If you wish to check this particular, right, you are getting value as 3575, right? And you can check out the stress diagram as well if you want to. I'll go to the post processing tab, okay, and I'll click on the beam stress results over here, so you can check this stress results from here. I'll click on the maximum value, right? So this is the value you can get. Now see, if you want to go more in detail, you can click on the post processing mode, click here on the beam stresses. Once you click here, you will be able to see the results, right? Once I click here, you can see that you will get a reference plane, and for this particular reference plane location, as it is moving over here, you can check out all the values, right? And you can see the stress values that we are getting 3575. okay, ultimately it is showing over here in terms of keeps per inch square. That's the difference only. You need difference of the unit only. So that's how you can manually validate the result. Now tell me in the comment box how you will validate the displacement part if you want to calculate it manually. So that will be your exercise.
We hope that you enjoyed the session, and if you feel that we are bringing value to your structural engineering concepts, share this particular video to all the beginners